So these collections are used only while you are implementing your logic with a specific data structure. In the sense, pure software engineering, we call it as pure architecture building and application development. So while you're building your product, there are some constraints that you need to follow. There is certain rules and regulations we set forth for improving our performance and all, and we select a design pattern for that. So if you ask me what is design pattern again, um, there are a lot of design patterns. So from starting a very simple singleton set to MVC, there are a lot of logical implementations for design models. How well you can implement a model just depends on that. So you can just explore it, but the thing is, we will not go in depth over that because no one again will not ask that. If you are asked about those design patterns or collections and all, it means that in India, if you speak about INR, it means that you're applying for a job of at least 30 LPA or 20 LPA with an experience of 3 years. So it happens only in the very big companies like Google, Microsoft, Citrix, like that. But still, we do have a PPT covering these things. Just go through them. So keeping these things aside, let's get back to this regular Python course. Let's discuss about conditions. So I think you are now familiar with what is reference by ID and reference by value, right? So for example, I declare 1, 2, 3, 4, b equal to a dot append 3, print b. Is that what we discussed in the earlier class? Oh my gosh.
Yeah, in earlier class, like I think we spoke about all the data types which are mutable, unmutable, and.
Did we not discuss about this?
Yeah, append also you did. We also did the copy thing, the shallow copy and deep copy stuff.
Oh yeah, so
Then you showed the dictionary. You went to the dictionary.
okay.
Yeah.
So in that, yeah, this is same as well when you discuss about dictionaries. So it happened like that just because you are when you are doing this one, it is a deep copy of that element, right? Your ID will be the same. It is called as reference by ID. But for dictionary, if you do this copy operation, it's a shallow copy, right? So the idea of this is you need to be able to understand or interpret in a correct way. So deep copy in a dictionary, if you speak about dictionary terms, deep copy is an operation which is powered by the reference of ID. So how can I say this? Did you work on Linux environments? I mean, if you have idea about soft link and hard link, then I don't think you will have. So, okay, fine. So reference by ID in the sense, it will be attached with, you are dealing with IDs in this case. So you're appending 3 to A, but still B gets appended because ID of A is equal to ID of B. So this is the reason. Right?
You mean to say like if ID of A and ID of B are equal, is it? I mean, I understand here you have written B is equal to A.
Yes.
But is it a again, I'm confused whether it's like a shallow copy or deep.
Yeah, shallow in the sense, what is the shallow in the sense it is not deep. Deep in the sense it's not shallow. Deep in the sense very deep, right? So if it is deep, it is like you are hitting the ID. If it is not deep, you are not going till the ID. You are thinking on to value itself. It is reference by ID, right?
Okay.
So it is deep copy. I mean, I'm speaking about dictionaries, not lists.
Okay.
Because you told that we discussed about dictionaries in the earlier class, right?
Yeah. Yeah.
So because this copy, update, these are not available for lists.
Okay.
But this one is available for list, which is nothing but reference by ID. Yeah, the conditionals goes like this. Python has this set of rules, default rules. Whenever you come across a colon, there should be an indentation. What do I mean by an indentation is this. Whenever you come across a colon, there should be a space. Basically, by default, it is 4 spaces, which is equal to 1 tab. Depending on the operating system, it's kind of, you can manipulate it. So by default, it is 4 spaces, 1 tab. And you write your logic. Your logic will be independent to this section itself. This will be a localite. For example, we call this level 1 and we call this as level 0, just for our understanding. You got this, right? So this will be level 0 and this, whatever it is level 1. So if I declare some other if here, this will be level 2. I mean only this space. So it looks like this is the child of this one. This is the child of this one. So this indentation is very important in Python. And there are no other set of rules that you need to really care about if you are acquainted with this indentation. This indentation comes into picture for conditionals, functions, classes. Oh, what happened? Ouch. This is just another helper tool from this Sublime. I don't know how to take it off. So class elements, and then for loops, we'll come across these things. So let's start about the conditionals first. If is a conditional, and the only condition that is available in Python is if. We check the condition here. If the condition is true, then do some action. If it is not true, it's your choice, leave it. So for example, if 1 is equal to 1, print condition met. You got this printed, right? If 1 is equal to 2, which is never a true, nothing happened. So it's your choice. If you don't want, if your condition is not met, do this thing. Print condition not met. Right? Again, it depends. It's just a print statement. Don't get confused about this one. If you execute this, if 1 is equal to 2, which is never true. So it goes to else part and prints whatever it is there. Here I wrote condition met. That's why it printed out condition met, but actually condition did not meet. Confused or clear? Hope it's clear. So you really need to bother about what the conditions that you are implementing in this if. So for example, let me just ask user an input. He's entering a input. If a is equal to 1, then a is 1. Else a is not 1. If I'm executing this, enter a number. Sorry, Sublime doesn't have this feature. So if I enter 1, it says A is 1. It is like that. But if I have another choice, what if I enter 2 or 3? It just says it's not 1. So there's something else called switch case statement, right? If you're from any other language like that. We don't have switch case here. If only handles that. We call it as else if. The short form is elif. I mean the syntactical representation. Elif A is equal to 2, then A is 2. Else print A is not 1, nor 2. So if you say 2, A is 2. This is how you represent it. And it is like, what if, when a condition gets true, when a condition gets false, that you need to be very carefully understanding. You need to understand it very well. So if I say something like this, if I enter a number, it says A is 1 valid. If I enter 5, it still says A is 1. Do you guess, do you have an idea why?
Is it because of the else statement, like which is not indented properly, or
If it is not indented properly,
in the sense like if it is within the if statement?
no, if it is an indentation problem, you will get an indentation error.
Okay.
No, if it is, as long as it is an integer, it's gonna be true, and that's it. That is why it's gonna stay in the first statement. It's not gonna go to the else if. I think that's the one because you put it as an integer.
Okay, let me take it off.
Okay, let's see. Yeah.
Now what? Okay. How about this now?
Because just you just mentioned true because there is no condition basically. True is a condition, but it's gonna be what is the false thing here?
No, it's not like that. So if at all your condition is true, then it will get printed. That's
Yeah,
why
right.
it is getting printed, but you're not actually checking anything. You're just by default giving the condition as true.
Yeah, that's the default condition. Yeah, that's why it is staying on the first statement, it seems.
So your condition is already true without any logic there, without irrespective of whatever A is. You are mentioning that your condition that you have given in if clause is true. So make a note of this thing again. If you meet a condition which is true, you will not be processed to further ellipse or else. So for example, I'll just give a equal to 1, and then I'll just give a. Oh, sorry, I will not confuse you much this time. I'll just give true here. So if you meet your first conditional, which is a equal to 1, well and good enough. See here, something happened. A is equal to 2 now. Just a second. This is never right because, yeah. This is weird. Thank God. So it's a encoding issue. Yeah, I got it. So as long as this condition is met, we are now typecasting it to integer and giving input as 1, which is assigned to a. So a is equal to 1. The condition is met here. So it is printing a is 1. A is 1. And still this condition is true, but still it is not traversing to this because it will break its conditional whenever the conditional is true and enter the indentation. After the indentation logic is implemented, you are out of your entire conditional. Hope it is clear. So on what cases conditional will become true? If I give a, okay, I'm not confused again. I took it off. So if it is true, it will print the print statement, right? It gave an output. So if I give 9, what do you think it will be? It's still given output. If I give 0, there's nothing printed. So to make your understanding a bit easier, condition is met. Condition is not met. So when I give an empty list, sorry, we are restricting it to integers. Let's take it off. So, okay, let me do this thing. So I gave a is equal to empty container, in the sense empty list. It says condition is not met. I gave something called empty tuple. It says condition is not met. So I say some container element. It says condition is met. I'd say some empty set. It says condition is not met. I say dictionary. It says condition is not met. It means it is evaluating all the empty data structures to false. So if you name it across, also 0 is defaulted to false. But whenever you give some value, it is true. Whenever you give an integer, it is true. It means just make it as this one. It still says the condition is met. And you can also pass this as an empty list here. It says the condition is not met. Hope everybody is cautiously following. If at all you have any doubt, you can just repeat myself again. But still you need to understand these conditionals. Are we clear with this so far?
Yep.
Again, if you want to compare, I mean the comparative operators in your conditionals. So for example, if you want to test 1 is greater than 2, which is not the case, it says condition is not met. This is how you compare. You can also use greater than or equal to. It says the condition is not met, which is very much true. If you say this, the condition is met because it is true. Same thing goes for less than or equal to. The condition is met. If it is less than, the condition is not met. And as we just have mentioned, a equal to b. So a is equal to 2, b is equal to 2. Then it says the indentation error because there is an indentation error. it says the condition is met, but I'll just say A is B. It says the condition is met again. So is and equal to are evaluated to test if it is equal to or not. I mean, is equal to B or not. But what is the difference between is and equal to? It's another important interview question.
Equal to it's compare, or it's
Sorry?
equal to it's um the value which is equal. I mean, whether it will variable whatever we are storing it, it's like A is equal to 2 means.
So basically it gives the same output. Is it so?
Yeah.
Are you sure?
Yeah, if it is A is equal to 2, like if we print A, then it gives the value of 2.
How about it now? What will be the output of this?
If A is B.
Sorry?
I guess it's gonna be the same 1, 2, 3, 4, but I'm not sure.
I mean, what is your condition? True or false?
True.
Great. How about now?
It should be false because a list has every other list has different IDs, right?
Is it so?
I guess so.
So you said the correct point. Is will be evaluating as per the IDs,
Okay.
and equal to you will be evaluating as per the values. That's what we speak about reference by ID and reference by value.
Yeah.
Okay.
So it's like that, and then this is one basic interview question. You can append it to the document. I did not have a chance to glance over that, but I'll look into it after this meeting. The document which you are appending, I hope you shared the document as well. Yeah, you can have multiple conditionals over there. So if one of which is satisfied, even then your condition is met, right? Because you're using OR. So this is about basic OR and then. So that's about that. And just a second. Yeah. So, yes, this is about the basic if, else, and elif conditions. If can exist independently without else or elif, but elif should exist or come into picture only in the presence of if. Else should only come into picture in the presence of if. I think it is very clear. I don't have to repeat it again, but I'll repeat it again. Just listen cautiously. If can exist independently, else and elif cannot exist independently. They need if to be declared. So that's about it. And then we can straight ahead enter into loops. Usually I follow some document for functions and loops. Let me just that. There are two types of loops actually. It depends on your segregation again. So definite and indefinite loops, I can say. So definite loops are something which you don't have to be much cautious about. For example, for loop. Okay, before that, Let me just give you a brief intro. A is equal to 1 to the 4, 5, let's say. For I in A, print I. This is one way of defining a for loop. This is by a reference to value. You can also define a for loop like this. For I in range length of, or for I in range 10, let's say, print I. If you say, sorry, print, it is going to print the range of numbers, right? So for all these iterations, print the value of A of I. If you say this, you're going to get an error, but I'll show you what. So you got all these elements, right? Till the 5th iteration. So for the 6th iteration, the length of this is just 5. So A of 6 is not there. A of 0 will become 1, A of 1 will become 2, like that, but still A of 6 is nothing here. So we'll commonly restrict it to the length of that A minus 1. Why minus 1? Oh, sorry, in this case, it will be length of A. Why is it so? It is 2, 5. No, there are 5 elements, so the length is 5, but the indices must be 4. Right? Yeah, exactly. Did you understand it?
Yeah.
But it's not taking all the list elements. See, it's coming up to 4 and then stop.
Which one? Uh-huh.
When you say A minus 1, it is giving until 1, 2, 3, 4.
It's not giving 5th element.
Length of A is 5. 5 minus 4 is 5 minus 1 is 4, which will be the part of index. So 0 to 4 will be the range.
But length of A minus 1 is excluded, right?
Oh yeah, sorry, got it. We discussed it already at start stop step, right? So yeah, that's a good point. So this is about range. You know the difference between range and X range, right?
Range is something, whatever within that range. For example, 0 to 10 means it takes within that range. But X range, I'm not sure what it is.
Okay, range and X range are same, but in Python 2 X range is there, but in Python 3 it will not have any X range because, for example, A is equal to range of, let's say, 10. Print, let's say B. So we discussed it already. This is one way of declaring a list. So we got this right. This is all a list of elements unpacked in a for loop. So this is about range. That's it. If it is 0, I mean range by default takes from 0 to 10. The outer part is excluded. Just we discussed previously. So X range is something similar to range, but it will take each iteration at a time. I cannot show you now in this interpreter because it's Python 3. So what happens is, if you declare a range function, every 10 elements, all the 10 elements will be coming into your RAM. But for X range, only one element for each iteration will come into your RAM. So it's like just like a generator function we call it as. So, or an iterator function we call it as. So your RAM will not be occupied by all the elements. One iteration, one element per each iteration is what you will get into your RAM. So the performance is improved. But why it is taken off in Python 3? Because we are implementing range as X range, and there is no need to bring all the entire elements into the RAM at all. So now in Python 3 itself, you're bringing each element at a time in the RAM. So that's about it. And these are the two kinds of for loops that we'll give. If I have to talk about, and I can also declare directly like this, because it is referenced by value. We can also directly access this. Got this, right? So this is about a basic intro of for loop. This is while loop, while true. Let me just declare print hey. When I say this, it goes infinite times, hey, until I kill it. So if I am not able to kill it like this, yeah, killed it. So you need to be very careful about while loop, because you're not really traversing by reference or index. You're traversing by the logic, right? So what I would do while I use for loop is, I'll just say some count is equal to 0. While my condition, let's say some a equal to b or something like that. Now to make sure this is not turning into an infinite loop, and count less than, it depends on my logic. If I'm dealing with a list of some 1000 elements, I'll just give 1000. If I'm dealing with a list of 100 elements, I'll just give my 100 elements. Print some logic to do, and then increment the count. By the way, this is the way we increment in Python. This is more or less equal to count is equal to count plus 1, right? So I'm incrementing the count twice, actually speaking. Right? So this gave the output of 50 times, because for every step it is incrementing twice. If you want to see more details, just print count as well. Got this, right? There are 50 elements here. For each iteration, the count is getting incremented to 2. So these two are one are the same. I mean, count is equal to count plus 1 and count plus is equal to 1. So if we do this one, maybe 3, you will get it incremented by thrice, right? So this is about incrementing. And if I say I is equal to 100 and count is greater than 1, let's say, and decrement your count, even then it works. So this is about decrement operator. Just a second. Yeah. This is about the decrement operator. You can also use this multiplication and division operators as well. So that's not needed now. But yes, we can use that as well. But again, if you increment this operator, count is already 100. It is always greater than 1, and you're incrementing it. It's again infinite loop. So make sure that you're not falling off into the infinite loop. So this is called as indefinite loop. So we are traversing through a conditional, based on a conditional. We are traversing through by reference of value or data. We call it as a for loop. I think that I made a sense in defining these two loops. So while you're using loops, there are certain operators that you can make use of, and they come in handy. One is break to continue. So these are the two things I wanted to discuss much. But before that, let's discuss what a loop is. This is the flowchart for the beginners, the complete beginners. So there is a condition that we declare always in the loop. While the condition is satisfied, even the for loop, it works on a conditional that is defined by the length of that data structure that you are giving inside that as an input. For example, you see this till this is done, traversed. That will be the condition here for loop. If it is yes, circle around in this loop till it becomes yes. Till it becomes no. When it is no, come out of this indentation. So this is the indentation again. Indentation defines the looping. It will just traverse like this, like this, like this, and then comes out. This loop comes out of this loop when the condition is false. So when a condition will be false for loop, that will be now. You got nothing, right? So there's nothing printed out. So if you give empty data structure, it runs out of its length. So it comes out of its loop just like that. And then the same thing goes for while loop as well. And break does this thing. Whenever a condition is met, you are breaking the statement. When you break a statement, again, it comes out of that indentation. In the sense, it comes out of that loop. So this is what break does. A loop will be revolving like this. But if the condition is met with break, I mean, if you're meeting your iteration with a break, it says like, it makes the condition as false. I mean, in the sense, it ends your loop and you will come back to the outer indentation level. And continue will skip that current instance and will continue that loop. It means whatever you print after the continue, it will not work. You just go back to the loop for the next iteration. So to show what it actually is, let me make use of this one. Let me just declare some container of elements for I in J. Sorry. God, catch up code, I think. So print I. You get all the elements printed. So if I is equal to 3, let's say, break. If I declare this, you'll get the first iteration, which is nothing but 1, and after evaluating this condition only, you got this. So to be more specific, print I is not equal to 3 yet. So for the first iteration, I picks up the value of 1, which is not equal to 3. That's why it went to else statement and printed it out, and then it's like it came out of this conditional, but still it is in the loop because this is the indentation of the loop. This is the indentation of the conditional. So again, I is 2, still the same process. Again, I is 3. When it is 3, the condition is true. Now there is a break here. So this break will just break this out of this loop. That's what you got here. So after 2, there's nothing that is printed. So if you see continue, nothing will happen still. So, but how could I say this? Okay. So, yeah, I'm just doing nothing. Just to pass it on like that, I just declared pass. So whenever it met 3, it is not going to else. right? The condition is satisfied here. That's why it just give the next element. But if I declare print hey, see, whenever it met the condition as 3, it also gave this print statement. But see, it gave the print statement, right? But when I declare continue, it will not give this. So the rest of the logic that is declared after continue will be invalid. And it will skip into the next iteration, but it will not break out of the loop. Is it clear so far? Everybody got the nerve of it? Or anybody nervous?
No, yeah, it's okay.
Yeah, got it.
Okay. So that's about 3 statements. Past, you can just use it anyway to just, so for example, if I don't declare anything here, it says EOF. So, I mean, some syntax is missing. Like that, some expected intended block. Because there has to be something when the condition is met, right? Like this. So that's why in order to pass it off, I'll just declare pass. That's about pass, continue, and break. So these things you can just go ahead through the PPTs. I hope it is clear for you about the loops and conditionals, and we'll discuss about the functions if you have no doubts. So for loops, you can just declare the the data structure and iterate over like this, just as we have discussed. But be very careful while you're dealing with the while loop. And also do use this a plus is equal to 1, not this old traditional way of incrementing. So this is like I actually this PPT was from 1 point versions of Python, so it's like that. Yeah, your tasks for tomorrow I would like to give is zip and enumerate. What are those? You need to teach me that, the syntax and their use case. Got it right? So these are regarding something. This has something to do with loops, actually speaking. Do you have any idea about this too? Anyone?
Something you know.
Good. So all of you got homework then. So come back with me with these 2 things, what they will do. So I think we can close off the session with this for now. We can start off with functions, and we'll really catch up the speed, like I said, in the next class. Any doubts till now?
No.
How is it going on? Is it good? Is it helpful for you?
Yeah, it is.